Are you ready to dive into the fascinating world of generative AI? With terms like transformers, attention, and embeddings flying around, it can feel like you're lost in a sea of jargon. But fear not.
Today, we're going to break down the essential terminology you need to know to navigate this exciting field. Get ready to level up your AI knowledge and impress your tech-savvy friends.
Welcome to our comprehensive guide to generative AI terminology. As this groundbreaking technology continues to reshape industries from healthcare to entertainment, it's more important than ever to understand the key concepts and terms that underpin it.
Whether you're a curious beginner or a seasoned developer, this video will give you the foundation you need to engage with the rapidly evolving world of generative AI.
First things first, let's talk about the different types of models you'll encounter. At the top of the hierarchy are foundation models. These are the big kahunas, the models with millions or even billions of parameters trained on vast amounts of data. They're designed to be versatile and adaptable, serving as the bedrock for a wide range of AI applications.
Within the realm of foundation models, you'll find the stars of the show, large language models, or LLMs. These are the models that have taken the world by storm, capable of generating human-like text, answering questions, and even writing code. GPT-3, Llama, and Falcon are just a few examples of the LLMs that are pushing the boundaries of what's possible with AI.
But not all language models are created equal. While LLMs are the heavyweight champs, their smaller siblings, small language models, SLMs, are making waves in their own right. SLMs may have fewer parameters, but they're faster, more efficient, and perfect for specific tasks. If you need a model that can run on a smartphone or handle a niche domain, an SLM might be your best bet.
Of course, language is just one piece of the AI puzzle. Large multimodal models, or LLMs, are the Renaissance artists of the bunch. These models can handle not just text, but images, video, speech, and more. They're the key to building AI systems that can truly understand and interact with the world around them.
Now that you've got a handle on the different types of models, let's dive into some of the key terms you'll encounter when working with LLMs. First up, prompts. A prompt is essentially the question or instruction you feed to the model to get a specific response. It's like casting a magic spell. The right prompt can conjure up anything from a haiku to a movie script.
The model's response to your prompt is known as a completion. And the process of generating that completion, that's called inference. It's the moment when the model puts all its training to work and produces an output based on your input.
Under the hood, LLMs are powered by tokens, the building blocks of language that the model processes and generates. The more tokens a model can handle, the more context it can take into account when generating a response. That's where the concept of a context window comes in. It's the maximum number of tokens the model can process at once.
But tokens alone don't determine the quality of a model's output. There are a host of other factors at play, like temperature, which controls the randomness of the output, top N and top P sampling, which determine how the model selects the next token, and the dreaded phenomenon of hallucination, when the model generates incorrect or nonsensical information.
To keep these models in check and aligned with human values, researchers employ techniques like RLHF, reinforcement learning from human feedback, and constitutional AI. These approaches involve training the model to adhere to certain principles and respond to human feedback, ensuring that the outputs are not only coherent but also safe and beneficial.
But training an LLM from scratch is no small feat. The process begins with pre-training, where the model learns general language patterns from a massive corpus of text. Then comes the art of prompt engineering, crafting the perfect prompt to elicit the desired behavior from the model. Fine-tuning allows developers to further specialize the model for specific tasks, like answering legal questions or writing poetry.
Of course, even the most carefully trained model can make mistakes. That's where evaluation metrics like Perplexity, BLU, and Rouge come in. These tools allow researchers to assess the quality of a model's outputs and compare its performance to human-generated text. Benchmarks like Big Bench, MMLU, and Superglue provide standardized tests to push the limits of what LLMs can do.
But LLMs are just one piece of the generative AI puzzle. Let's take a quick detour into the world of multimodal models, or LMMs. These models are the Swiss Army knives of AI, capable of processing and generating not just text, but images, video, speech, and more.
At the heart of LMMs are techniques like contrastive learning and multimodal embedding spaces. Contrastive learning allows the model to understand the relationships between different modalities by comparing and contrasting positive and negative examples. Multimodal embedding spaces provide a common language for the model to represent and manipulate data across modalities.
One of the most exciting applications of LMMs is in the field of image and video generation. Generative Adversarial Networks, or GANs, pit two neural networks against each other, a generator that creates new content and a discriminator that tries to distinguish real from fake. Through this adversarial game, the generator learns to create increasingly realistic outputs.
Variational autoencoders, or VAEs, take a different approach. These models learn to encode input data into a compressed representation, then decode it back into its original form. By sampling from this compressed space, VAEs can generate new content that's similar to the training data.
But LMMs aren't just for creating pretty pictures. They're also the key to building AI systems that can truly understand and interact with the world around them. Models like CLIP, contrastive language image pre-training, learn to match images with their textual descriptions, enabling applications like image search and caption generation.
As generative AI continues to advance, efficiency and scalability are becoming increasingly important. Techniques like quantization and pruning allow developers to compress models and remove unnecessary parameters, reducing the computational cost of training and inference. Low-rank adaptation and soft prompting provide ways to fine-tune models with fewer resources.
On the hardware side, GPUs, graphics processing units, have become the workhorses of AI development, providing the parallel processing power needed to train and run these massive models. Distributed computing techniques like fully sharded data parallel, FSDP, and distributed data parallel, DDP, allow teams to scale up their training efforts across multiple machines.
But with great power comes great responsibility. As generative AI models become more sophisticated, so too do the risks of misuse and abuse. Prompt injection attacks can manipulate models to generate harmful or biased content. Data poisoning can introduce malicious examples into the training set, causing the model to learn undesirable behaviors.
To combat these threats, researchers are developing new techniques for AI security and robustness. Adversarial training involves exposing the model to specially crafted examples designed to fool it, helping it learn to resist attacks. Differential privacy techniques allow models to learn from sensitive data without revealing individual examples.
But security is just one piece of the puzzle. For generative AI to truly live up to its potential, it needs to be deployed and integrated into real-world applications. That's where the emerging field of LLM Ops comes in, the tools and practices for developing, deploying, and monitoring AI models at scale.
From data loading and indexing to prompt engineering and evaluation, LLM Ops covers the entire life cycle of a generative AI application. Platforms like Weights and Biases and Prompt Layer provide tools for experiment tracking, model versioning, and prompt management. Deployment frameworks like TensorT and VLLM make it easy to package models for production.
But perhaps the most exciting development in generative AI is the rise of open-source models and frameworks. While proprietary models like GPT-3 and Gemini have garnered much of the attention, a new wave of open-source alternatives like Llama, Falcon, and Vicuna are democratizing access to state-of-the-art technology.
These models, often developed by academic institutions or nonprofit organizations, are freely available for anyone to use, modify, and build upon. They're the foundation of a growing ecosystem of generative AI applications, from chatbots and virtual assistants to creative tools and scientific research aids.
As we look to the future of generative AI, it's clear that we're just scratching the surface of what's possible. With each passing day, new models, techniques, and applications are emerging, pushing the boundaries of what computers can create and understand. It's an exciting time to be alive and an even more exciting time to be working in this field.
But with excitement comes responsibility. As generative AI becomes more powerful and pervasive, it's up to all of us, researchers, developers, policymakers, and users alike, to ensure that it's developed and deployed in a way that benefits society as a whole. We need to prioritize transparency, accountability, and fairness, and work to mitigate the potential harms and unintended consequences of these technologies.
At the same time, we can't let fear or uncertainty hold us back. The potential benefits of generative AI are too great to ignore. From accelerating scientific discovery and solving complex problems to enhancing creativity and enriching our daily lives. It's up to us to seize this opportunity and shape the future of AI in a way that reflects our values and aspirations.
So whether you're a seasoned researcher or a curious beginner, I invite you to join us on this journey. Learn the terminology, explore the techniques, and start building the generative AI applications of tomorrow. The future is wide open and it's ours to create.
As we wrap up this whirlwind tour of generative AI terminology, I hope you're feeling more confident and inspired than ever. We've covered a lot of ground, from the basics of language models and multimodal learning to the cutting-edge techniques of LLM Ops and open-source development.
But this is just the beginning. The field of generative AI is moving at a breakneck pace, with new breakthroughs and discoveries happening every day. To stay on top of this rapidly evolving landscape, you'll need to keep learning, experimenting, and collaborating with others in the community.
So don't be afraid to dive in and get your hands dirty. Start by picking a model or framework that interests you, and try building a simple application. Join online forums and attend local meetups to connect with other enthusiasts and experts. And most importantly, never stop asking questions and pushing the boundaries of what's possible.
Because at the end of the day, generative AI isn't just about the technology. It's about the people behind it. It's about the researchers and developers working tirelessly to push the state-of-the-art forward. It's about the artists and creators using these tools to express themselves in new and exciting ways. And it's about the users and consumers whose lives will be transformed by the applications we build.
So let's rise to this challenge together. Let's build a future where generative AI is a tool for empowerment, not oppression. Where it's a catalyst for creativity, not a substitute for it. And where it's a force for good, not a source of fear or uncertainty.
The road ahead won't be easy, but it will be rewarding. And with the knowledge and skills you've gained today, you're well equipped to take on whatever challenges come your way.
So go forth and create, experiment and explore, and above all, never stop learning. The future of generative AI is in your hands. Let's make it a bright one. Do us a favor and please hit subscribe, and maybe even tell a friend. Now let's keep the discussion going, taking a look at